Hello everyone, welcome to the lab 3, the introduction to Proteus lab. So this lab is for the mechanical students who are taking CO221 digital design course. But anyway, this lab will also work as a rescheduled lab for computer students who couldn't participate in lab 3, which we had before the university closure. So basically in this lab, we'll be looking at a electronic circuit simulation software called Proteus. In fact, Proteus has not been developed only to simulate circuits. It has other features as well. Things like PCB creation. PCB stands for printed circuit boards. Most of you might already know what the PCB is. So the Proteus supports things like PCB creation and other stuff as well. But here in our course, mostly we'll be using Proteus only for circuit simulation. So with Proteus, you can easily, in fact, develop circuits that include ICs, LEDs, resistors, or capacitors, or anything like that. You can easily add them to your design and then connect them and finally simulate them. We'll quickly go through a demonstration of how you can use Proteus to simulate a circuit. In fact, how to build a simple circuit and then finally simulate the circuit. Um, so that's the plan. So this lab sheet is already uploaded onto Field, so it contains the lab exercises you need to complete for lab 3. Okay, so we'll go to Proteus. So when you open Proteus, this is how it looks like. And the first thing you need to do is to create a new project in Proteus, just as similar to what can be seen in other softwares. So you should create a new project. So for that you can use this new project wizard, and so obviously the first thing you can do is giving a name to your project. We will call it CO221 lab 3, and then you can specify a location for your project, and then you can click on next. And then the immediate next thing you should choose is whether to create a schematic or not. So in our designs we need a schematic, so you need to create a schematic. So for that also you can choose a schematic from a template. So we'll be using this default template for the schematic, so you can choose that and then you can go ahead by clicking on next. And as I told you earlier as well, you can use Proteus to create PCBs, printed circuit boards. But in this lab and also in most of our labs, we'll not be creating PCB layout. So we don't need to create a PCB layout. So you can choose this option, which asks it not to create a PCB layout. And you can go ahead next. And also here, it asks whether to create a firmware project. So firmware projects, we are using them for circuits that includes microcontrollers. So we are not including any microcontrollers in our circuits. So we don't need to create a firmware project. So we'll choose no firmware project and go ahead by clicking on next. And finally, you can click on this finish button to get to this window. So now you can add components, electronic components to this window and then connect them properly, and then finally simulate the circuit to see if it works as you want. Now in Proteus, you can work in couple of different modes. One mode is the selection mode, which is the default mode. So with the selection mode, you can select components, you can drag them here and there, and sometimes you can connect components together. So things like that you can do with this selection mode. But when you want to add a new component to the circuit, you need to go to this component mode. So it's essential to go to this component mode before adding any component. So once you go into that component mode only, you will be able to add components. Add components meaning electronic uh, devices. So you first need to go to the component mode, and then you have to specify the device or the component you need to add to your circuit. So that you can do with this button. So I hope you all can see this. So just next to this toolbar, you have this section where it has this P and L two buttons. So by clicking on this P button or parts button, you can choose devices to be added to your circuit or components to be added to your circuit. So here now we'll build a simple logic circuit. In fact, we'll be verifying the functionality of a NAND gate with a circuit built with Proteus. So you can add logic ICs to your design. So we will now add a NAND gate to our design. You can look for devices by typing them on these keywords text box. As you already know, the IC number of the NAND gate is 7400. So since we are using ICs from the LS logic family, we can add 74LS00 to our design. So you should keep in mind that you should try as much as possible to include devices that are physically available. So when you're trying to add a component to your circuit, you need to try to add components that are physically available. So 74LS00 is an IC that is physically available to you. You can go and buy an IC named 74LS00. Since we have been using LS logic family when we were building circuits in lab, we'll be going ahead with 74LS series. So choose ICs from 74LS series when you are creating your circuits in these labs. So 74LS00, we'll choose it. So that's an AND gate. Now you can add this component to your circuit by clicking on this window. Now when you click on the window, it will place this NAND gate on your circuit. So in fact, this 74LS00, if you look at its data sheet, it will not in fact contain only one NAND gate. So it will contain multiple NAND gates. But here, Proteus shows the NAND gate as a symbol, not as a sort of an IC symbol. So it just shows it as a logic symbol. So when you try to add another NAND gate, so it will, if you carefully look at this, so the first NAND gate is named U1A. So the component here is U1, that is the 74LA00 IC. So inside U1, you have one NAND gate, which is called A. So that is why it is named A. And inside U1 component, you have multiple NAND gates. So the second NAND gate you have is it has been called B. So likewise, you can add more NAND gates. So if you keep on adding NAND gates, you can see you can add 4 NAND gates with the same U1 name. That is because one NAND IC 74LA001 IC contains 4 NAND gates. So you can observe that as well here. So once you add the fifth one, it will be named U2. That is because a new IC is needed to instantiate that NAND gate. So now here we'll be doing our demonstration only with one NAND gate. So we'll remove the rest. So now the gate is there with us, the IC, one gate from the 74LA00 IC. We have it with us, and then now by just having only the gate we cannot check the functionality. So I told at the beginning, now we are going to check the functionality of the NAND gate. So of course, if you want to see the output that is coming out from this NAND gate, you need to connect something to the output. So in labs, in physical labs, what we were connecting were LEDs. So we can of course add LEDs to our circuit in Proteus as well. So now I'm going to add an LED to the circuit. You can search for LED by typing it on this keywords text box, and if you search for an LED, you will get a lot of options. If you look at here, you have multiple options for a LED. But remember, now we are going to simulate this circuit. So when we are simulating the circuit, we should be able to see the LED getting light up. Otherwise, it's not going to be interactive and you can't verify whether it's working properly or not. So make sure when you are adding an LED, make sure that you are adding an animated LED. So you have multiple options for an LED. One option is that you can add animated LEDs. So if you add an animated LED, it will light up when you simulate the circuit. So you have different color options for LEDs as well. Here you have animated LED blue, animated LED green. If you want to filter these animated ones, you can search directly for animated LED and it will filter only the animated ones, and then you can add we'll add a red LED. So you can add it by clicking again on this window. You can add a component. Now the LED is there with us. You can rotate these components and move them here and there by going back to the selection mode. So you can move them here and there, and also you can rotate them by right clicking on the component. You can rotate it. So we have the LED with us. Now one thing important, when we were doing labs physically as well, I told you that it's important to connect a resistor in series with an LED. When you are going to connect an LED to a circuit, it's important to connect a resistor in series. That is to limit the current that is flown through the LED. So if you don't connect a resistor in series with a LED, there's a chance for a huge current to flow through this LED, which will cause the LED to burn. So all these safety measures you have to keep in mind when you are designing circuits in Proteus as well. So in fact, a simulation software like Proteus, we are using them to check whether the circuit is working as we want before you go and implement it with real components. So you have to include all the components that you will be using in your real circuit in Proteus as well. So remember, when you are connecting LEDs to your circuit, remember to connect a suitable resistor in series with the LED. So for that, you have to choose a resistor. We will search for a resistor here. Now for resistors as well, you have a lot of options. So we'll go with this first option, resistor. Now we have it with us. Now the default value I got for this resistor is 10K. So depending on the resistor you choose from that device selection window, the default resistance value might vary, but here the one I chose is having 10k resistance, a default 10k resistance. So we need to change this resistance. If you have a 10k resistor, will the LED light up? No, because that's too large. So you need to make sure the resistance is set to a proper value. So if you can remember, we were using 220 resistors in labs. So you can specify the resistance. I quickly went through that step. So you can change the resistance and things like that by going to properties of this component. So you can do that by double clicking on the component. So you can go to properties window of the component by double clicking on the component. Now when I double click on this resistor, I can see that I can change the resistance value. So earlier it was 10k, now I have changed it to 220. So likewise you can do this for other components as well. So if you are adding a component that has variable parameters, you can set them by going to this edit component window, to be precise. So properties or the edit component window, you can access the edit component window by double clicking on the component, and then you can change values. Okay, now we have the components, the main components that are needed to create this circuit. Now one thing we have missed is a way to give inputs to this circuit. Now the inputs to this circuit are these two lines, 1 and 2 lines. So these are the inputs to this NAND gate. Now those two inputs also we have to give by using some components available in Proteus. So one such component that you can use to give inputs to a circuit, a digital circuit. It has to be a digital circuit to give inputs using the device that I am going to use now. You can add this component called logic state. So there's a component called logic state. In fact, this one is kind of like a virtual device, but we'll be using it to give inputs to our circuits. Later we'll look into ways of actually giving an input using real components. So for now we'll use this logic state. So logic state, you can choose that and then you can add the logic state to a circuit like this. Now for the two inputs we are having, I'm adding two logic states. So of course you can add multiple logic states or multiple components by clicking again and again on the window. I hope you already have realized that. So we have all our components now. Now one thing is missing. So if you look carefully, now we have all our components with us, but one thing missing is that the power. So we have not given power to our circuit yet. Now for these ICs, Proteus automatically connects power lines, that is 5 volts and ground. So 5 volts and ground, if you can remember, when you were physically building these circuits, you were connecting VCC and ground to the IC. So that VCC and ground connection to the IC is done by Proteus automatically when you are simulating the circuit. So that is done by Proteus for us. So you don't need to explicitly connect power lines to the IC. So that you need to keep in mind. You don't need to connect the power to the ICs. But every other place where you need power, you need to connect them explicitly. Now, for example, if you look at this LED output part, there you need to connect this resistor, this end of the resistor to the ground, if you can remember. So otherwise it will not light up. So that we need to create a path for the current to flow. So when the NAND gate outputs 1, that is there's going to be 5 volts here. So by just having only 5 volts here, you cannot light up the LED. In order to light up the LED, you need to connect this end of resistor to ground. So those power lines are not connected by Proteus automatically, because Proteus does not know we have to connect it. So we are the ones who know about our design. So you have to connect the ground explicitly to this end of the resistor. So for that, you need to add a ground line to your circuit. So that you can do by going to this other mode called terminals mode. So this is another mode in Proteus. We already have looked into two modes, selection mode and the component mode. Now this is another mode in Proteus, which is called terminals mode. So you can click on this terminals mode, and then there you have uh, options to add power lines to your circuit. Now we only need the ground. So ground, we can add it like this. Now we have all the components that we need to build our circuit. Now we have not connected the components together yet. So all these components are unconnected still. So if you simulate this circuit now, you will not see any output. So in order to get the proper circuit, you need to connect the components together. So for that, you can go to this selection mode or the component mode. You can be in one of these modes. When you are going to connect components, you can go to selection mode or component mode, and when you move your mouse cursor over a terminal, you will see that there's a red dot popping up. So that means you can connect something to this. So you can click on there and then connect ground like this. Now you need to establish a connection between LED and resistor. You can do that connection as well like this. Inputs will be connected like this. Now that's all. So now we are done with our circuit. So this is all. So compared to physically building a circuit, this is very easy. So that is because we are only doing the simulation with the software like this. So now we are done with our circuit. Now the only thing we are left with is simulating the circuit. Now you can simulate the circuit by clicking on this play button, which is available at bottom left. I hope you all can see this. At bottom left, you can see this play button. By clicking on this play button, you can simulate your circuit. Now you can see here these logic states are initialized to 0. When you just run the simulation, they are initialized to 0. Now if you look at the truth table of an AND gate, when both the inputs are 0, the output is 1. Now you can change one of these inputs to 1, and still the output is 1, because that is how an AND gate works. So you can change other input also to 1, and still the LED is on. That is because it's outputting 1. And when you make both the inputs 1, according to NAND's functionality, the output should be 0. So because the output is 0, you cannot see the LED lighting up. So LED goes off. Now you can see, you can easily simulate a circuit like this in Proteus. Now if you want to stop the simulation, you can click on the stop button here. When you stop simulation, it will stop the simulation, and also you can now modify your circuit. Now yeah, that is also one thing important. When you are in simulation mode, you cannot modify your circuit. You cannot add components to your circuit. You cannot remove components from your circuit. You cannot move your components when you are in simulation mode. So you have to stop the simulation and go back to this normal mode to modify your circuit. So this is all about the demonstration I was planning to do. And now I hope you all can go ahead with the lab exercises, which are mentioned in the lab 3 sheet. So this lab sheet I have already uploaded into fields because we did this lab for computer students earlier. So that lab sheet is there. So the same lab sheet you all also have to follow. There are like 3 exercises. They are not that difficult anyway. So simple exercises. You can do those exercises in Proteus, and also when you are doing those exercises you have to follow the same guidelines I have posted on fields regarding online labs. So this is also going to be a online lab. Therefore you have to follow the same guidelines I have posted. So when you are creating projects, when you are naming your projects or folders, you have to follow the same guidelines. And finally you have to submit a single zip file containing all your project files. The computer students who couldn't participate in lab 3 also can do these exercises and submit them. So I'll consider this as a rescheduled lab for those students. So I'll post the deadline and the submission link on fields, so you can submit your submission there. If you have any issues, questions, you can ask all of those questions in the discussion forum on fields. Thank you.